Hello everyone. Today we will discuss about Unit 5 RF system and design concepts until RF subject, and this is the syllabus. Directly we will go for the topic. Power amplifiers. Right, we will see what is power amplifier. RF amplifier designs are differ significantly from low frequency approaches and require special considerations. Is nothing but in low frequency circuits we have amplifier, right? That amplifier design is somewhat simple, but in case of high frequencies, in terms of power amplifiers, in terms of radio frequencies or microwave frequencies, the design of this amplifier is somewhat difficult. Somewhat special considerations are needed, and most of the high frequency amplifiers can oscillate, and it is terminated with the load and source. The impedance value is going to mismatch. The matching networks can help stabilize the amplifier by keeping the source and load impedance in appropriate range. In general, to make a stable of amplifiers, the stability is the first step, right? And so we can use gain noise circuits for making the circuit amplifier in a stable system. And this is the amplifier relationship. We have a left side RF source, IMN, input matching network, and next one we have amplifier, and corresponding bias will be given here, and next we have a output matching network, this OMN, and we have a load. And this IMN is called as input matching network. It's going to match the impedance between RF source and amplifier, and output matching network is used to match the impedance value between amplifier and the load value, right? And this gamma in is considered as input reflection coefficient, and this gamma s will be considered as source reflection coefficient. This gamma L is given as a load reflection coefficient, and this gamma out is represented as output reflection coefficient. And this one is the simple generic structure, right? And it's a general amplifier diagram. And input output matching networks are needed to reduce the undesired reflections and improve the power flow of capabilities, right? And here amplifier is characterized by its S matrix, and we have a DC bias also. And what are the key parameters to evaluate the performance? This is gain and flatness. Gain flatness is given in terms of dB, and operating frequency in terms of bandwidth, and using the unit of hertz, and output power in decibel, and power supply requirements in terms of voltage and current. It's in voltage and ampere, and input output reflection coefficient in terms of VSWR values, and finally noise figure in terms of decibel. And the above diagram is simply redrawn like this. Here the source will be replaced in terms of Vs and Zs. Source having self impedance value is Vs and Zs. Load is in terms of ZL. And here we have amplifier section. This is characterized by S matrix, and this source gamma is the source reflection coefficient, gamma n is the input reflection coefficient, gamma load reflection coefficient, and gamma out is the output reflection coefficient. And from this diagram we are going to consider only the input section, right? We are going to consider only the input section, which is separated here. And here we have Vs, and we have Zs, and here we have Zn, that input impedance of this section. And here we have a B1 dash and A1 dash, and gamma S and gamma In, and this A1, B1, A2, B2 represents the input, and that means incident reflected powers of amplifier 1. And this A1 dash, B1 dash, A2 dash, B2 dash represents the entire direct power flow of this circuit. And here we are going to redraw the signal flow graph. The entire structure will be drawn by using signal flow graph. This S1 and S2 S1 to S2 is considered as amplifier, and Bs is the source, and gamma L is the A2 dash, B2 is considered the point considered as a load point. And like how we are going to consider this section, similarly we are going to consider the small section here. This is the input section. So Bs is source, and B1 dash, A1 dash, gamma S and gamma N. And we can write the value of source. First RF source connected to the amplifier network. The incident power is given as B1 dash, and P incident is equal to B1 dash squared divided by 2, and this is given as 1 by 2 modulus of Bs squared 1 minus gamma n gamma S square. And the source node is given as Bs is equal to 2 of Z0 by Z0 space 0 into Vs. and Z0 is the characteristic impedance, zeta is the source impedance, gamma is the source reflection coefficient, gamma n is the input reflection coefficient. Input power is nothing but actual power. The actual power P in the input terminal of the amplifier is composed incident reflected power arrives. This P in is equal to P incident into 1 minus gamma n square. And the value of P in substitute the P incident value. So P if you are going to substitute the P incident value, you will have this value. And maximum power transfer is nothing but the input impedance is matched with the complex conjugate of the source impedance. Zn is equal to Zs star, or in terms of reflection coefficient gamma is gamma n star. Then the maximum power transfer from source load will be occur. Nothing but the input impedance is the complex conjugate of source impedance. The input impedance is the complex conjugate of source impedance. So you can say that the maximum power will be transmitted here. So we can write the maximum power transfer theorem. P is equal to P incident in terms of where by condition is gamma n is equal to gamma n star, gamma s star, and this is the corresponding values. And finally we have incident power as Bs will be Bs square by 2, and we can write the transducer power gain. And transducer power gain is something but the gain of the amplifier when placed between the source and load. The transducer power gain is nothing but the gain of the amplifier when it is placed between source and load, and the GT is given as power delivered to the load divided by all power from the source, PL by PA, and we have corresponding values. And this is the final answer. GT is the final answer, transducer gain. And next one is unilateral power gain and feedback effect of amplifier is neglected. Then there is S12 is equal to 0 means that is called as unilateral power gain, and this value of S1 GTU, where S12 value will be 0 in this equation. Additional power relations, we have available power gain at the load, and also we have a maximum power. GA is nothing but available power available from the network divided by total power available from the source. And power gain, the operating power gain is defined as the ratio of the power delivered to the load to the power supplied to the amplifier. This is known as power delivered to the load divided by power supplied to the amplifier, PL by PM. Just you can simplify the equation, we will have an answer. Thank you.